Hi, I'm Seth Rotenberger, and I'm going to show you how to use Vehicle Design Validation, or VDV, to meet standards for the direct and indirect vision of a vehicle. Let's head into VDV and create a new component for the new simulation we are going to make. I want to rename this component so that it's easier to reference and understand later on. To start off, we need all of the geometry of the car, which has already been added as base data. I now need to add an ellipse. There's a lot of documentation here explaining the different standards for vehicles. Here we can set different standards and loadings. I make sure that my loading is for EG plus co-driver. Our vehicle class needs to be a Class A. The measurements filled in come from the base data that we imported. It can be customized and changed for different vehicles. Again, we have the imported measurements, but this time for head clearance space in the vehicle. And finally, the display of the ellipse can be changed here. Let's now add the direct vision of the driver. The standards for direct vision needs to be compliant with our previous standards as well as with our vehicle. We can now add the mirrors of the vehicle. Let's start with the driver's side. It needs to be a Class 3 mirror to be compliant for the standard. I simply select the face of the mirror and the pivot point. The prime point needs to be in the top corner and will be aligned to the horizon later on. I am going to repeat the same process on the other mirror. This time, I make certain that the passenger side is selected. We now need a camera for the back of the car. I select the point and then change the direction of the lens. The shape and size of the view can be changed depending on what camera that is being used. The last detection device that we will add is a rotating pointer. This is going on top of the car. The rotating pointer needs to be slightly above the roof so that it can more easily detect the surroundings. Again, the size and scale of the field of view can be modified to meet a specific standard. We now need to make sure the car cannot be seen through by the driver. And to do that, we will make it an obstruction. I simply select the different bodies that make up the car, and they now obstruct the vision of the driver. Let's add a grid target. We need to select the direct vision we previously made. The loading can be changed and customized for individual assessments. Here, we want a circle around the car. Now that we have finished our setup, we can create the interceptions of the visual devices. We'll start off by selecting our direct vision, the grid target, and obstruction features. Next, let's add the driver's side mirror, and then the passenger side mirror as well. We'll add the camera, and then finally the rotating pointer. We now have a way to visualize the field of view of all the different devices that were added to the vehicle, with the camera and mirrors shown in the back, and the direct vision and rotating pointer in the front. It's easy to see the blind spot of the car by showing and hiding the sheet body that was created for it. We can repeat this process and see how the different devices overlap. Here we can see the interception of the rotating pointer and direct vision. Let's look at the mirrors and how they overlap with the camera added to the back of the car. You can see the different sheet bodies not only correlate to the different mirrors, but also both the left and right eyes of the driver that we created with the ellipse. Let's recap what you have seen. You saw me open a car in VDV and import the base data and measurements of the vehicle. I then added an ellipse and set up a standard for the vehicle. Then I created the features for visualization, such as direct vision, 2 mirrors, a camera, and a rotating pointer. You then saw me make the vehicle an obstruction, and the road the grid target. Finally, I created a ground interception and showed how direct vision, mirrors, a camera, and a rotating pointer affected the field of view of the driver. I would like to thank you for your time and attention.